This is geometry lesson 13.5. We are looking at the tangent of an angle. So we're going to use that word a lot today. Tangent is a certain ratio of the sides in a right triangle. We'll also look at sine and cosine. You may have heard those before. You might have noticed these buttons on any kind of calculator that you've worked with. It looks like sin and cos and tan. That's for sine, cosine, and tangent, just abbreviations there. So we're going to be today specifically looking at the tangent. And it's just a ratio of the sides in a right triangle. Your big idea says the tangent of an angle is a trig ratio or trigonometric ratio determined by the angle measure, with which you can determine segment lengths and angle measures in right triangles. So this is again specific to right triangles. They're very special triangles, and that's why we study them so much in geometry. We've looked at some very, very special ones like a 30, 60, 90 and a 45, 45, and some other ones like a 3, 4, 5, 5, 12, 13. This now is going to help us find missing sides and missing angles of just any right triangle. It doesn't have to be a special one. So I'm going to kind of just break this down real easy for you. Right here in the definition of a tangent, it's always going to be the length of the leg opposite angle A, if we're talking about the tangent of angle A. Key thing is that it's opposite on top, and it's the length of an adjacent side to angle A. And we know that adjacent side means next to, and opposite is across the triangle. That's what the tangent ratio is. So it's from the angle, it's across the triangle, that side length, and it's adjacent to, it's next to. Now, every one of these right triangles also has a hypotenuse. And for the tangent, we are not using hypotenuse. We will use it for sine and cosine, but for tangent, we will not. So when we're looking for the one that's next to it, we're not going to pick the hypotenuse. We're never going to use the hypotenuse for tangent. Okay, so real quick, in these pictures up here, if I was going to write out the tangent ratio of angle A, so here's angle A right here, it's always the opposite over the adjacent. So what does that look like here? Here's angle A. Opposite side means across the triangle. So that would be little a from angle A. Every angle has its own. And then the adjacent means next to angle A. So here's angle A. The adjacent sides are both C and B, but C is the hypotenuse. We're not using that. So the adjacent side would be B. Okay, so that right there, that's your tangent ratio of angle A. So it's the side across and the side adjacent. Now, if I know what degree measure this is, every triangle, right triangle with that degree measure will have the same ratio of sides. So they may be bigger or smaller, but if I know the degree measure here, the opposite side divided by the adjacent side will always give me the same value in any right triangle that has the same angle. That's always going to be true for all of them. Just like we looked at with 30, 60, 90s, but now we're going to be looking at everything. All right, so let's say we wanted to do the tangent. Let's pick a different letter. Let's do tangent of y. So going from there, again, it's opposite over adjacent. The opposite is going to be little y. And then adjacent, there's two sides that are adjacent to it. One of them is the hypotenuse. We're not using that. So the other adjacent there would be x. All right, so opposite is across, adjacent is next to, not using hypotenuse. This will make more sense when we actually use numbers. So let's slide down. We're going to apply this ratio to special triangles first so you can see it, and then we'll start using it for just any old right triangle. So we're going to start off here with a 45, 45, 90 and see what that looks like here. So I'm going to first label it B, C, D, doesn't really matter. I'm going to pick a random side length here, so I'm going to call this 5. Now, if this is a 45, 45, 90, we know it's x, x, x radical 2. So I know this is 5, and I know this is 5 radical 2. So I don't need the tangent ratio to help me find any missing sides because this is a special one. But since we've studied it so much, I'm going to relate this to tangent, and then we'll make the connection to other triangles. So if I say, what's the tangent of angle D? Again, that's the opposite over adjacent. So from angle D, the opposite side is 5, and the adjacent side that's not the hypotenuse is also 5. So the ratio there is just 1. It's a 1-to-1 ratio. That is always going to be true for a right triangle with a 45-degree angle. The opposite side and the adjacent side will always be equal. And we've studied that. That's why it's an x radical 2. But this is now going to apply to all triangles with different degree measurements. Now, they're not going to have the same ratio, but they all have the same ratio for each specific angle. So that was the tangent of angle D, which means this is equal to the tangent of 45 degrees, because that's what angle D is. So my tangent button is in a different place, depending on the calculator, but I would press tangent and then punch in 45. You can just hit enter and it will give you the answer. But if you're going to do something with this 45, like multiply or divide, you do need to close the parentheses there that you see. But if I'm just trying to find out what is the tangent of that, you can see closing the parentheses or not closing it is not going to make a difference. Now, if you're working at home and you don't have a graphing or a scientific calculator, use your phone. If you just open up your calculator app and then you turn your phone horizontally, it switches. I don't know if you knew this, but it switches to a scientific, and I have my tangent right there that I can use. All right, so you can do these on your phone. You don't need a special fancy graphing calculator to do it. All right, so we made the connection there, and maybe you're not quite making the connection yet. That's okay. So let's look at a 30, 60, 90. I'm going to put the 30 here and the 60 here. We know that this is x and 2x and x radical 3. So let's put some real numbers to it. I'm just going to pick a number. Let's make this 10. So 2x would be double. That would be 20. And x radical 3 would be 10 radical 3. Okay, so I need to make sure that this all works out. So let's label our sides or vertex here. Let's call this x, y, z. So if I'm going to find the tangent of angle z, it's the opposite side over the adjacent side. So from angle z, the opposite side is 10 radical 3 across the triangle. The adjacent side is 10, not the hypotenuse. So adjacent is next to. Here's angle z. The side that's next to it is 10. Now that would simplify. These 10s would cancel. So this is equal to radical 3. And so that's what the tangent of 60 degrees is equal to. Those two sides in every right triangle that has a 60-degree angle will be in that same specific ratio. And we've already kind of covered that, but let's see what that looks like in the calculator. So if I take tangent of 60, I get this number, which maybe doesn't mean anything to me. But if I take the square root of 3, notice that it's the same thing. So the tangent of 60 degrees is radical 3, which is equal to this decimal. So let's do one more. Let's do tangent of y. I'm going to write it a little differently here now in parentheses. Tangent of angle y. Opposite over adjacent. Opposite here is 10. Adjacent, that's not the hypotenuse, is 10 radical 3. That would simplify. The 10s would cancel, leaving me nothing on top, so I do need to put a 1 there. And then radical 3 left over on the bottom. So that should be equal to tangent of what angle was it? It was 30 degrees. Okay, so if I punch in tangent of 30, I get this number. And if I do 1 divided by radical 3, I also get that number. Okay, so the tangent of 30 is that ratio. The opposite side compared to the adjacent side of any 30-degree angle will always be in this same size comparison. That's what a ratio is. Okay, so that relates it directly to these special triangles. Now let's look at how this relates to just every right triangle. And again, it's only in right triangles. So we're at a location, it's 30 meters away from the base of the flagpole. The angle to the top of the flagpole is given here as 34 degrees. We're going to determine the height. So let's call it x. That's what we're looking for. We're going to do this two different ways. So we're going to use this other angle as well. So remember, the angles of a triangle always add up to 180. So if I wanted to find this angle, I could do 180 minus 90 minus 34, and I automatically know that this is 56. So we'll do this two different ways, once with the 56, one with the 34. Now, if I had all three sides, I could use sine, cosine, or tangent. And in the future, once we've studied them all, you'll have to determine which one to use based on the information that's given. But because the two sides that I'm working with here from the 34 or from the 56 are the opposite and the adjacent, we're not using hypotenuse, then that means I am using tangent to do this. So the way you write this out is the tangent of the angle, just like we did up here. Now, we're not going to call it A. We're going to go ahead and just use the 34 degrees. So the tangent of 34 degrees is always the same. So these sides in comparison to each other across from a 34-degree angle will always give you the same ratio, will always give you the same decimal if you divide them. So I need to set this up correctly. Opposite over adjacent. Opposite over adjacent. Okay, so the x must go on top and the 30 must go on the bottom. Opposite over adjacent. This is how it sets up. The tangent of 34 is equal to x over 30. Now we need to solve this. Now let's set the other one up. What if I was doing 56? So if I did tangent of 56, what does that look like? Opposite to 56 is 30. And then the adjacent, not the hypotenuse, is x. So the tangent of 34 is x over 30. The tangent of 56 is 30 over x. These are the only two situations that you're going to see, so we need to make sure we know what to do in the calculator for both of these. So you can always put these over 1, because anything can be put over 1. And think about what you would do if you were cross-multiplying your proportion, and that will tell you how to solve these. So for this one, in the cross-multiplying spot, I've got those two numbers. X would get times by 1. So x is just going to equal this times this. So I'm going to write it out. You don't have to write this out once you get in your work, but for your notes, you probably want to write it out. Tangent of 34 is being multiplied times 30. Now, this is not going to get me a perfect number. When we're not working with special triangles like 30, 60, 90s, we don't get all nice whole numbers everywhere. So we're going to round it to the nearest meter in this case. So all I have to do in my calculator is tangent of 34 times 30. So we'll round that to the nearest meter, nearest whole number. 0.2 means it's going to stay 20. All right, and if I was doing it the other way, using the 56, notice that the cross multiplying here does not put the 30 times 56. Now, we've talked about in these proportions, you can actually mix and match where everything goes as long as the diagonals stay the same. So I could put this x up here and tangent of 56 down here, and this proportion still remains equivalent. Okay, it's still equal. So if I did that, I would end up with the 30 on top, and then I would end up, so I'm going to flip-flop these, I would end up with the tangent of 56 on the bottom, and that's going to end up equaling x over 1, which is just x. So in this case, when it doesn't set up diagonal, I'm actually going to divide. So flip-flop these. You actually, eventually you don't have to write this out. You just know that you're going to divide, and you can just go ahead and do that. So 30 divided by tangent of 56. And notice I get the same exact answer. So x, and I probably should use the squiggle because I'm rounding, is approximately 20 meters. Okay, those are the only two ways it's going to set up. Multiply when they're diagonal, flip-flop, and divide when they're not. Okay, to the back. So example number 2, when they say find tan, they're just asking for the ratio. So they're just looking for a fraction that's simplified. That's the ratio. So the tangent of D is equal to something over something, opposite over adjacent. So angle D, the opposite is 40. And then be careful, 41 is the hypotenuse. So the adjacent that I'm looking for is this, which I don't have right now. So I have to go find it. This isn't some special triangle, so I can't use any of those special 30, 60, 90 ratios. So the only way that I'm going to be able to find this third side is Pythagorean theorem. A squared plus b squared equals c squared. You can always use this when you have 2 out of 3 sides of a right triangle. Now, we really don't like using this too much because it's tedious. We end up having to square all these numbers and write them down. It's just a lot. So I'm going to simplify this for you. Plug them all in. So the legs go in for A and B. And then always the hypotenuse goes in for C. And then the next step is when this would get tedious. You'd have to square everything and write it down and then minus it from both sides and then all this other stuff. So let's speed up the process. We can go ahead and minus this right now before getting the big numbers and just avoid them altogether. So I'm going to be left with a squared equals, and now unfortunately this doesn't work the way you would like it to. Like 41 squared minus 40 squared is not equal to 1 squared. That's not how it works. But the calculator will handle the big numbers without actually us having to write them out, right? So 41 squared is this number, 40 squared is this number, but I don't need them. Okay, I can just punch in 41 squared minus 40 squared, and boom, I get my answer. So from now on, make your life easy and just do it like that. Don't expand the exponents, just go ahead and subtract them in your calculator. Now I need a, so I square root this. We should know the square root of 81 is 9. So this is 9. If not, plug it in your calculator. And so my ratio here is 40 over 9. And that's it. That's the tangent ratio. So they're really not looking for much here. It's just the comparison of the sides. We were just missing a side here, so we had to go get it. 40 divided by 9 is not a nice decimal, so please leave it a fraction. Now, once I have this ratio, I can go find an angle measure. This question's not asking me to do so, but here's how you do it. You're going to use what's called the inverse function of the tangent. Okay? And in your calculator, this is what it's going to look like. So you're going to find it right above your tangent button. Okay, you see it right there in blue. So to get to it, you hit second and tangent. And then what we're going to do is we're going to actually go ahead and flip-flop these. So inverse means flip a fraction. So the inverse trig function here, the 40 over 9 switches places with the d when I take the inverse. So 40 over 9 goes in here. And this is going to get me the measure of angle D. All I have to do is plug in the ratio that I have. And the calculator knows that if I have a right triangle and I have a 40 to 9 ratio, then my angle must be, and again, these are not going to be perfect numbers. We're not looking at 30, 60, 90s. I'm going to round this to the nearest degree. So it's going to be about 77 degrees. So if we have the ratio and we want to find the angle measure, we flip-flop these, which creates this inverse, and we just use that function on the calculator. All right, let's fly through some practice problems and then get you started on today's work. So here again, they're just asking for the ratio. That's all they're asking for. So my final answer is just a fraction, should be simplified. So it's from C. So the tangent of angle C, tangent of C equals opposite over adjacent. You need to remind yourself, opposite over adjacent. So from C, the opposite is across the triangle. That's 30. The adjacent is next to it, but we're not using the hypotenuse. So that would be 16. And I need to simplify that. So if I divide 30 by 16, I don't get a decimal that I want to use. Leave this a fraction. But if I divide them both by 2, 30 divided by 2 is 15. 16 divided by 2 is 8. That's now a fully simplified ratio. And again, you can do this in your calculator. To bring up your fraction function, you hit the green alpha button, the button right next to it, the X button. That's the shortcut for your fraction. You put in 30, you put in 16, you hit enter, and it will simplify it for you. Okay, so the tangent ratio of angle A. Here's angle A. Opposite is 16. Adjacent, not the hypotenuse, adjacent is 12, and that simplifies to 4 over 3. And that's the tangent ratio of angle A. Okay, 3 and 4 now, we're going to use this trig to find a missing side. We'll have to round. We're not going to get perfect numbers. So we still write this out the same way, but now we're going to put the angle measure in here, and we'll be missing one of our pieces of the ratio. So again, we'll eventually use sine and cosine, and we'll have to recognize what sides do we have. Today's just tangent, but the reason we're using tangent is because from the angle of 28 degrees, the two sides I'm relating to each other are the opposite side and the adjacent, which means I use tangent. If I was using opposite and hypotenuse or adjacent and hypotenuse, then I would use sine or cosine, and we'll get into that soon. So this ratio sets up opposite over adjacent. So x over 14. This is a practice problem like we did on the front. Set up your cross multiplying so you know what to do. This means times, so I'm just timesing these together, and I'm going to round my answer. So tangent of 28. Make sure you close your parentheses, times 14. And we're rounding this to the nearest tenth. So that should be one number after the decimal for tenth. 7.4 is the approximate length of that side. Okay, for number 4, this one would obviously set up the same way, and then you would end up multiplying. So let's go ahead and do this one the opposite way so we see it. So we'll have to use the other angle to make that happen. So 180 minus 90 minus 37 is 53. So let's just pretend I didn't have the 37 and I got the 53. You can do it either way. We showed that on the front. But I want this to set up the other way here so that you know what to do. So again, from the angle, we have the opposite and the adjacent. We don't have hypotenuse, which means I have to use tangent. So tangent of 53 equals the opposite side, which is 10, over the adjacent side, which is x. And when I go to cross multiply here, it's not in the right spot. So what I do is I flip-flop these. 10 stays on top. Tangent of 53 comes to the bottom. That's equal to x over 1, which is just equal to x. And we're just going to go ahead and solve it. So when we see this setup, again, we're going to do division. Make sure you divide the correct way. 10 divided by tangent of 53. And we'll round this to the nearest tenth, 7.5. Okay, and then last two. Now we're going to go ahead and use the ratios to find the missing angle like we did right here. So we always do tangent of whatever the angle is. We're going to call it x. Notice we have three sides here though. So I could use sine and get it. I could use cosine and get it. Today we're just going to use tangent. But if you have all three sides, you can use whichever one you want. It's your choice. Now sometimes it's going to be dictated to you which one you have to use depending on what you have. If you only have adjacent and hypotenuse, then there's a certain ratio that you have to use. So we're going to go ahead and use tangent. We're going to say tangent of the angle, which is x, equals the opposite, which is 65, over the adjacent, which is 72. When we want to flip-flop these, because we want to find out what x equals, we want this to equal x. We go ahead and we do the inverse function. So tangent to the negative 1, plug in my 65 over 72. If I'm going to write that out here, tangent negative 1 is above it, so second tangent, 65. And then you don't actually have to do the fraction. You can do divided by 72. And we are rounding to the nearest degree. These are, again, not going to be perfect measures. We're not looking at perfect triangles like 30, 60, 90s. These are just random triangles. So x is approximately 42 degrees. And that's it. So if you have two sides, you can find an angle using sine, cosine, and tangent ratios. Today we're just doing tangent. So tangent of x must be opposite over adjacent. So 36 is my opposite, adjacent is 48. To find the angle, I have to do the inverse function here. So 36 over 48 switches spots with x. Inverse of a fraction is a flipped fraction. Inverse here of a trig function, they just switch spots. Calculator handles the rest. So I hit second tangent to bring up the inverse function. 36 divided by 48. Hit enter. X is approximately, now the 0.8 will round this up, so 37 degrees.